Hello and welcome everybody to today's webinar. Today's webinar is being recorded and will be sent out to everybody within 24 hours. If you have any questions, please go ahead and type them in the questions box. We will be sure to take time for questions at the end. Today's webinar is the System of Action, integrating real-time IoT performance with intelligent asset management for water and wastewater utilities. Today's presenters are Becky Tomaszewski. She is the Vice President, Product Vision and Engineering with Cityworks. And we have Rami Naber, who is our Product Manager with Trimble Water. Okay, thank you guys. Go ahead.
Thank you, Lindsay. Today we have some really powerful things that we want to show related to IoT. But first, let's talk briefly about the declining health of our infrastructure. And if we focus on water, with main breaks, they're becoming more and more common. And the societal impacts are massive because the resource is so vital, and in some situations globally is becoming very scarce. America's water infrastructure score is a D. And to really understand the seriousness of a D, let's see what it means by looking at a few of the main points represented by that grade, which are mostly below standard, approaching end of service life with a strong risk of failure. And if you look at the statistics, it's no wonder that a 2018 study found that there was a 27% increase in water main breaks. Over the previous 6 years, each year, we experienced 240,000 main breaks at a cost of $2.6 billion to repair. This makes replacement of aging infrastructure the #1 concern for water utilities. And with that, it's estimated that we're going to need $1 trillion to maintain service and expand it in the future, and it's going to take us 25 years to accomplish that. Unfortunately, this problem will only continue unless we start to approach it in a different way with a new perspective. And in today's environment, this need to adapt and take a different approach is driving organizations to identify new ways to work safely and remotely while ensuring continuity of operations. And so what if we could do that? What if we could get ahead of that very first urgent phone call that comes in, and we could avoid the disruptions? And then we could avoid the damage that's a result of it by letting the pipes tell us about it and let us know what's happening in advance. And that's what we want to talk to you about here today. We'll be discussing our real-time IoT solution. It's a combination of Cityworks, Trimble Unity, and Telog IoT recorders. It's a real-time IoT solution for asset performance that will assist utilities with management of the infrastructure, improvement of customer service, and prioritization of resources and investment. Today, we'll be discussing each of the pieces that plays a role in this solution and give you a demonstration as well before opening it up for Q&A. And so what does the solution look like? That's what we're sharing. One company offering a unified full stack IoT solution. We're integrating two powerful platforms to create a unique and comprehensive digital platform with real-time asset intelligence, workflows, and analytics for transforming the way that water and wastewater utilities prioritize infrastructure maintenance and construction investments. This solution will initiate with Trimble Telog recorders in the field capturing sensor data, which is visualized and reviewed in Unity. And then based on that information, activities are created in Cityworks for field assessment and repairs. And then the accumulated sensor data, historical activities, and GIS are brought into Esri's tools for data sharing and analytics within the organization. Customers benefit from an integrated solution that will help them realize improved infrastructure performance, increased productivity, and better return on investment associated with infrastructure construction and operation. So to get us started and begin discussing the various pieces that are part of the solution and where it initiates, I'm going to turn things over to Rami.
Thank you, Becky, and hello, everyone. So let's start with the remote monitoring portfolio. So our Telog IoT recorders, recording telemetry units or RTUs, have been proven in the field for many years. They support a multitude of water and wastewater asset performance monitoring to reduce leakage and non-revenue water and better manage pressure on the water distribution system, also to proactively detect and minimize sewer overflows and environmental impacts on the collection systems. The RTUs are rugged, they're wireless, battery-powered devices that are easy to install and cost-effective to maintain. They provide a secure, accurate, timely, and reliable data with near real-time alarms for anomaly detection. So on the water supply and distribution side, the Telog RTUs and sensors support monitoring flow using our insertion flow meter, pressure and pressure impulses or water hammers, water level on tanks or reservoirs, and leakage using our acoustic leak detection sensors. And on the wastewater side, on the collection system, the Telog RTUs and sensors support monitoring rainfall, open channel flow level, and sewer overflows, including also lift stations. The RTUs can also connect to various types of sensors that have either digital or analog inputs, or we can connect with sensors over industry standard protocols, including Modbus or I2C and others as well. So all of the data that's collected from Trimble Telog family of IoT recorders and sensors feeds into the Trimble Unity remote monitoring software. It's a GIS-centric cloud and mobile software offering advanced workflows, analysis, and reporting tools to proactively monitor, measure, and improve asset performance, and detect anomalies to preempt issues that can cause infrastructure damage, disruption of service, and environmental impact. The software empowers your organization to respond quickly and effectively, reducing operations costs, improving regulatory compliance, and protecting public health and safety. And you can quickly gain asset performance visibility and awareness in a few steps. So starting with using the Trimble Unity mobile application to install the Telog recorders in the field, then set up the sampling and recording intervals and alarming thresholds to detect any operational anomalies and how these events are raised. Then be able to activate any performance KPIs you want to update in your GIS against assets that you are monitoring. So that will allow you to support GIS-based analysis and risk of failure assessment efforts that we'll show later on. And finally, use the built-in reporting and analysis tools available in Trimble Unity remote monitoring to monitor your distribution and collection systems. So now I will hand it back to Becky to present how our solution enables intelligent asset management by combining Trimble Unity remote monitoring with Telog and Cityworks and GIS. Becky?
Thank you, Rami. And so we wanted to give a little overview of Cityworks, just for those attendees who might not be familiar with the application. And so Cityworks is a web GIS platform. We have essentially two sides of the solution: our AMS, Asset Management Work Management System, and our permitting, land management, and licensing solution. These can be used independently or cohesively for an overall application and workflow across organizations. And then we expand this functionality with other plugins that are across our portfolio to provide tools that start to get into resource allocation with workload, budgeting tools, pavement management, public-facing portal to initiate and manage the permitting process and applications, analytics that are available through ArcGIS Insights and can immediately be hydrated with your application data from Cityworks. As well, we offer a storeroom tool for inventory and material management, iOS and Android native apps for field mobility, and then our application Respond, which is what we're actually highlighting as part of the solution in combination with operational insights to start to develop asset and risk strategies for the infrastructure. And so with that, I'm going to actually dive into those core activities within Cityworks Respond. And those really come down to, let me see, am I a little bit too far? Let's get back. And those come down to our core activities for public requests, which in this case is actually the initiation of those activities within a workflow. And in terms of the integration that we're showing today, this is starting with the IoT sensor data that's coming in, alerting us of an issue in the system. And from there, we're able to go ahead with Unity and generate the inspection for Cityworks, which allows us to take Respond out into the field and capture those observations, determine asset condition and performance, and identify what follow-up activities are needed. Based off of the observations that are being captured, the work orders generated in the system, this allows us to start to track more detailed data, getting into project management, contract management, the use of resources such as equipment, labor, and material across a work activity. And then as all this historical data is being generated in the system over the course of days, weeks, months, years for many of our clients, we're able to start to do reporting and analytics and bringing that information together within a spatial context in the GIS to give a greater in-depth view and help organizations with operational decision making. And so in terms of how we're processing that information and Respond, from here, those users are able to go ahead and let's just go back one. Those users are able to go ahead and process, as I mentioned, those inspections. So Respond is an application that's responsive and dynamic to their field devices. It allows them to be standing over the valve out in the field, a hydrant, a main, and view the spatial information in the same context. Their GIS data from Esri is presented. It's dynamic, showing real-time updates to the GIS and repositioning based off the location of the work activity. As they're going through and populating and performing inspections or interacting with activities in Cityworks, they have that context for other work activities that are taking place, real-time dashboards to give them more information, and the ability to see their GIS data and query and interact with it in real time to help assist with that information process in the field. And then as those activities are completed, it allows organizations to start to take that data into Cityworks operational insights. And from here, we can go ahead and develop a risk strategy or an asset strategy in the application. This is coming from an organization's GIS. From here, they're able to view in real time their GIS attributes, prioritize which fields start to go into play for their probability of failure calculations, consequence of failure, and the resulting business risk exposure. As well, as part of this integration that we're developing, we're able to also leverage the KPIs and metrics that are being established in Unity in relation to the asset performance and use that as well to start to review and query and define what the asset strategy looks like to determine the risk and prioritization of the infrastructure. And from there, we're able to start to perform analytics, to start to come into the system and take that information that's being captured from Cityworks, Unity, and Ops Dashboard to go through the process of looking at how that information can be visualized for data sharing and to provide analytics across the organization. These are tools that can be shared out in terms of reporting processes and updating, but also allowing those organizations to view in real time as information is being captured and displayed spatially across both Operations Dashboard and ArcGIS Insights. And so to show you what this actually looks like, Rami is going to go ahead and kick off our demonstration.
Thanks, Becky. Let me get control here. All right, so we'll show you an example using pressure monitoring to kind of walk you through the workflow and show you the capabilities of this solution. So what you're looking at here is the login screen for the Trimble Unity remote monitoring web application. I will go ahead and log in by entering my username and password. And once I log in, the application will show me the list of all the monitoring sites and location of these sites on the GIS map. I can also see any open work orders or inspections managed in Cityworks, all from within the same application. So first thing I want to look at the overall system health by opening the system health dashboard, which shows the various interactive widgets that summarize the health of the assets we are monitoring and the health of the Telog RTUs. Looking at the pressure impulse widget at the bottom here, we can see some critical impulses detected recently by the pressure sensors. So if we drill down to view the details, you could see that the outpost drive site had 17 severe impulses within that time period. And I want to look at, analyze and see what's going on there. So let me bring up the impulse and pressure data for that site. And you can see a lot of pressure fluctuations during the last 3-day time window of this report with impulses tagged on the graph color-coded by severity. Looking at this statistical summary, it shows a wide range in pressure within the time frame of this report. And the pressure impulse list shows the summary including pressure range for each of the detected impulses, some having pressure ranges of over 40 psi. So we can further analyze these pressure impulses and load the high-resolution sub-second pressure data to view the signature impulses that are being detected and look at those signatures. These impulses, if gone unnoticed, can cause water main breaks and infrastructure damage, especially in high-risk areas. So if we go back to the dashboard and we go look at the location of that site on the map, you can see this site is located in a pressure zone that had many historic leaks, as presented here via the heat map along the pipelines. There seems to be also an open work order that's managed in Cityworks. If we click on that, it indicates there is a water main leak that's being scheduled in the area as well. So we'll close that work order. And one of the values of the solution we're presenting here is the ability to create integrated views of data from Trimble Unity, GIS, and Cityworks that provide real-time insights across your organization. So if I go back to the dashboard and I can show you an example of an ArcGIS dashboard we've created that shows the GIS map, it shows the pressure impulse and alarm summaries from Trimble Unity, and the dashboard also brings in leak history and customer complaints reported and managed in Cityworks. We can filter the high pressure complaints and view the results on the map as well by clicking on that complaint from a customer, all from within the same view that can be shared across your organization. So now that we identified there's clearly a pressure issue in this pressure zone that needs to be investigated, we'll go back to the map and we'll zoom into the location there of the pressure regulating valve that's feeding this pressure zone. As you can see here, clicking on that valve will show the valve details from the GIS, and I can select it and create a Cityworks inspection to send out to field technicians to investigate. We'll go ahead and select the priority and add some recommendations and comments. And once that's done, we'll also choose the Cityworks PRV inspection template that's configured in Cityworks for the PRVs. And once I do that, you could see the PRV is tagged on that inspection already in Unity, and then creating that inspection will automatically send that to Cityworks and then progress it through the workflow. So before I hand it to Becky to show you how the inspection is progressed in Cityworks, I'd like to show you a couple of other key features that populate data in GIS and Cityworks. So let's go ahead and close this inspection that we just created, and we'll go back to the outpost monitoring site that reported these pressure impulses. And once I load this site, you could see the site details on the right-hand panel. I have activated pre-canned KPIs that on this site, which includes daily average, min, max pressures, and impulse count by severity. We can configure those KPIs to update the GIS data for analysis and risk of failure assessment. So in this example, the daily average pressure values is set up to update on the highlighted water main segments here showing on the map in the GIS. And once that data is available in the GIS, then you could access these KPIs and be able to use them for analysis. Another feature related to alarms is the ability to set up alarming thresholds and ability to raise events, Cityworks events, when these alarms are detected. So here I'm going to the RTU settings for that site, where I can update these settings. And some of the things I can update is the call schedules, sampling and recording intervals, and alarming thresholds. So I will update the settings to raise a low pressure alarm when the pressure drops below 30 psi and lasts more than 10 seconds. And when the alarm is raised, I want members of the central operations group to receive this alarm via email or text, depending on what's configured, and also raise a leak detection event in Cityworks on the pressure zone polygon in the GIS. So this event is configured to automatically create a Cityworks leak detection investigation that will be raised as soon as the alarm is triggered. So when I update this, now we'll go ahead and update these settings, and when the unit detects these alarming conditions, they will raise those events. So now I will hand it back to Becky to show us how this inspection we created on the PRV is progressed through its workflow and how we can use the data to create risk of failure assessment.
Thank you, Rami.
Becky.
And so what we're actually looking at here is Cityworks Respond, the application I just briefly described. And you'll notice as well that operations dashboard that Rami was showing, we're able to embed that within Cityworks Respond. Users have the ability here to start to filter and interact with the dashboard to identify certain types of customer complaints. But then we can also go ahead and search for that inspection that Rami just previously created in Unity. We're able to open that up and view it in the context of our GIS. Initially viewing here the information in a full view with all of our infrastructure information, other related activities that are showing nearby to give more context for items that are being viewed in the distribution system. And we're also able to zoom in and start to dive in more to the details of the attributes that are present there. We can see the location of that valve, where the inspection has been created, the symbology for that inspection. And we're able to now go ahead and, as I mentioned, view information side by side in the same context within Respond. Being able to view our inspection activity information in the same context as our GIS, and then for full visualization of the inspection fields, just missing the map. And from here, we can go ahead and start to populate some of our observations, going through and completing that information, and then going through and identifying information related to the condition of that asset and the performance that we're noticing here in the field. And from here, based off of these observations and the determined resolution to complete and repair this item, we're able to go ahead and start to initiate additional work activities. So I'll go ahead and complete these fields and start to populate some of the date and timestamp data for our record keeping reporting processes. Go through and mark that yes, a work order is needed, but the work order has now, this inspection has now been completed out in the field. And once I go ahead and save this activity, based off of logic that's been generated in Cityworks to identify criteria for generation of certain types of follow-up work orders based off of this inspection results, we're able to now see that a work order has already been generated in the system automatically. I can view that work order. I can see if there were other related activities that were part of this inspection that could be seen. From here, I can open that work order and go through and start to process more information as well. So if we were to say we immediately went out to the field and we wanted to view again where that information was located, I can see again that same context for where the inspection was created, the PRV associated to it, and other infrastructure within that area, and heat maps showing clusters of activity that are coming in from Unity. We can report that there was a replacement of that valve diaphragm, population of who completed the work with the date and timestamps. And if needed, we could also start to dive into more information here with tracking of the equipment, labor, and material that was consumed as part of this work order activity. And as I mentioned, there's also flexibility for tracking of project data, additional contracts, and allocating this back to certain budgets that have already been established within the organization. So from here, once I go ahead and save this work order and the activity is completed, we can move on to the next step in the process. And this is where all of that information, all the activity information that's being generated, the data from those KPIs that Unity is tracking and compiling and writing to the GIS, as well as the organization's GIS information and that attribute data comes into play here in operational insights in Cityworks. From here, we're able to start to go through the process to establish the priorities for our probability of failure. And you can see here that we're pulling directly from the GIS. So these are the GIS attributes for the domains in this region. We're able to go through and prioritize which attributes have the highest priority in terms of looking at the calculations here for the probability of failure. It's a similar process that we'll be showing next for the consequence of failure. But this is also where those KPIs that are being brought in from Unity, such as the number of leaks against certain mains, those are being able to be used and prioritized as well and consumed for this calculation and establishment of the probability of failure and consequence of failure going into the calculation of the business risk as well. So you can see here as I go through this process, I can go through and complete as more attributes are being added to really flesh out the calculation here for the probability of failure. And this is part of the flexibility with the application as well, given that it's coming off of GIS data for your organization. It's all real-time and accurate data. And it gives organizations the flexibility to decide what fields for their infrastructure are relevant for their goals in relation to their asset strategy program. And so next, I'm going to go through and start to complete the same process again for the consequence of failure. And so I'm looking here at different priorities, moving away from more so the attributes of the pipe for the material characteristics, such as number of leaks, material and diameter, and start to moving into more of those consequences in terms of the pipelining type, in terms of accessing and the consequences in terms of if there's a failure, what are the consequences in terms of providing that type of repair. Also the system zone, and additional information can be brought in here as well, such as soil type. As those calculations are completed, we can view that information here, and you can see as I'm filtering through the process here in ArcGIS Insights, as that data has been imported, I can start to filter down and look at the areas where the highest pipe leaks have taken place against material and BRE score, identify where those are spatially, and see the breakdown of the BRE score in relation to various makeups of the mains within our geography here. And this allows me to have that full view of that information that's coming in from Unity with our IoT and sensor data, Cityworks with our historical work activities, and then also pulling in that information from the GIS and the attributes of our infrastructure and providing it all in a spatial context to give that visualization for analytics for organizations, as we mentioned, to really start to help support that decision making within operations. And so with that, I'm going to turn things back over to Rami.
Thanks, Becky. So to recap, the integration between these powerful products we presented today create a unique and comprehensive digital platform with real-time asset intelligence, workflows and analytics that help you gain better insights into asset performance, shifting your focus from reactive to proactive asset management practices. And with that, you can reduce infrastructure failures and repair costs, improve customer service and response, and use this real-time performance data to support business risk assessment and probability of failure assessment to help you make informed decisions when prioritizing repair activities in high-risk areas and to ease your regulatory compliance efforts. So now we'll go ahead and open it up for questions. Take it back to you, Lindsay. See if we have any questions.
Thank you. Yeah, just as a reminder, this webinar was recorded, so it will be sent out tomorrow in case anybody was having some sound issues. But we'll give it a second to have people type in some of their questions. This one, another thing too, is we have someone else on the line here. His name is Adrian Newcomb. He is our Director of Product Marketing for Utilities and Public Administration with Trimble, and he's going to be helping out answer some of our questions. This question is for Adrian. What communication protocols do the Telog units use, and how often the data is communicated?
Hey, hi, Lindsay. Thanks for that, and hi to everybody. Thank you all for joining. So on that question, the IoT devices are of two flavors. One is a cellular device which calls out over the cellular networks that are 4G and also 3G where 4G is not available. And they will call out over a configurable period. So that can be anything from configurable to 15-minute call outs to several times a day. And that's really depending on the application that's required and also the desired battery life that the customer would like in that situation. The other protocol supported or wireless protocol supported is LoRa, which is an LPWAN technology used in IoT devices as well. And some of our IoT devices do support the LoRa also. And in that case, again, it's configurable down to 5 minutes or less frequent if necessary. And when I'm talking about call-out rates, I'm talking about the rates at which it reports to the cloud, the data to the cloud. So depending on the device, they're able to sample the data at much more frequent intervals. And you know, in some cases we have devices such as the impulse devices that Rami showed the data from there earlier, and those are capable of sampling at up to 256 times a second in order to get really high resolution data on to capture those very fast water transient or water impulse events that could be going through the system.
Great, thank you. Here's another one. Risk often includes consequences that go behind repair cost. Can you capture the consequence of the impact on populations served for a pipeline break that there is not a workaround for?
So in terms of that information, we can start to provide some of those related attributes tied into the GIS. And we've also been looking at ways to start to pull that information into those tools such as ArcGIS Insights. Actually, there was, if you looked at one of the cards in the bottom right for the template that we showed, we were actually pulling in data from the Living Atlas from Esri to show the population served in the different zones where the main breaks had taken place, to start to recognize that information in correlation to the severity of the main breaks and the density of the main breaks, recognizing the consequences there in terms of the amount of the population without service or within the disruption affected as well. So we're able to look at that information in that context of ArcGIS Insights, and also if that information is available in the GIS, we can start to pull that information in as well to operational insights within Cityworks.
Is the IoT data stored in your platform or ArcGIS? Big data stored through GeoEvent?
Yeah, so the IoT data is all stored inside our historian. So Trimble Unity is powered by Telog Enterprise Historian, and that's where it resides. We have, as we've shown you, we have KPIs that we can store in the GIS, or we have also APIs that allow you to pull that data and integrate with other systems, including SCADA, for example.
What are some example KPIs for wastewater?
I can take that. So we added some KPIs right now for the wastewater, including daily flow data, depth or level, average, min and max, and also peak data. So peak capacity, peak flow, and peak depth, including also rainfall, and peak 1 hour intensity of rain. And we are open to hearing feedback from our customers as well, and working with our customers to see what else, what type of other KPIs that they need to bring into this GIS for analysis, and we'll be able to develop those over time.
What is the recommended spacing of monitoring devices?
Adrian, you want to take that? It depends on the topography typically, but and
I'll
application.
take that, Rami.
Yeah.
I would say that it depends on a number of factors, some of which are, as you said, it depends on the topography of the area, it depends on the topology of the network, but probably the key one is what is it you're actually trying, what's the application, what's the key parameters that you're trying to measure. So, you know, for example, if you're measuring flow within a wastewater collection system to characterize I&I, well, you're going to look at citing your flow and level devices at key points in the system that will allow you to identify the drainage areas within the collection system that might be prone to the I&I. Whereas, you know, if you're looking at monitoring pressure within a distribution system, you know, you're going to be citing that depending on the topography and depending on the topology of that distribution network. So it really does depend on what it is you're trying to achieve, but also the specific environment in which you're trying to achieve that.
Can your IoT devices remotely monitor water quality parameters such as pH, conductivity, chlorine, etc.?
Yeah, I'll take that one, Lindsay. So yes, they can. We've connected to a variety of both water and wastewater quality devices, monitoring a whole variety of parameters. We do pride ourselves that our IoT portfolio has capabilities to monitor pretty much any parameter of the water or wastewater collection distribution systems that a utility would wish to monitor.
Okay. Are the low F and co-F risk factors fully customizable by customers, or were you drawing from a pre-populated list of options in the demo?
So those options are completely configurable by organization, and that's part of the intent and flexibility with Cityworks Operational Insights, is to allow organizations to develop that strategy that matches their goals and is in alignment with their asset management plans. And so basically organizations can just point to their GIS. So any fields that are available in their GIS attributes associated to their infrastructure, those are able to be viewed and used as part of that prioritization. They can have numerous fields associated there, but it's allowing those organizations to derive it with their own priorities in place and represented there. So there's a lot of flexibility to how these can be generated and defined going forward.
Okay. Do you have the ability to import third-party device information such as flow and totalization from meters to create hydraulic modeling information or repair work order information?
We have various ways we can bring in data from other third-party sensors, either through connecting them with the RTUs, or we can use file drops that we can bring that data into the Trimble Unity platform, and then from that we can create alerts on that data.
Are geometric networks required on all pipeline data?
Not for this initial release of this solution. So geometric network is not required to be able to leverage these capabilities.
Can you address data security?
I'm assuming this is referring to data security from maybe the Telog units and sensors. If that's the case, we use private communications and VPNs to communicate data from the RTUs back to our cloud and historian. And we also have white papers around security and data reliability within the Trimble Unity and Telog platform that we can share if you're interested.
Can Trimble Unity create custom reports for regulatory compliance requirements?
At this point, there are telemetry reports available, but not custom reports. It's something we're looking at doing. You could leverage existing reporting capabilities that you have today by bringing that data into your reporting platform through either APIs or through the KPIs and the demonstrations we did today with the GIS integration.
Does the Cityworks Response app have the capability to collect document data, signatures, customer data, or create real-time external alerts? They're curious how some of this could be translated into use for monitoring a lead service line replacement program.
So Cityworks Respond does have the ability, and I'll address each of those items as I go through. For document data, there's no required format. Any type of attachments can be included. So you can have the ability to attach photos, videos from the field, PDFs. So if you have SOPs that you want to include or legal documents that need to be included as well, those can all be attached within Respond. We also have the option to have a signature panel included on the activity type. So if you need to have the capture of signatures within the field, you have the ability as well to embed that as part of that process, and it can be designed for the workflow type and maybe not exposed on all activities. We also have the ability to track the customer data, and for real-time external alerts, we can do that as well. There are a few different methods. We do have a whole platform within Cityworks of APIs and webhooks to enable integration and alerts through other systems. We also have out-of-the-box email notifications that are available as well that can be used to help to assist with those external notifications and alerts within the system. And I think that covers all the items that were asked there.
Thanks. Can I send all the data, all the field data to my own servers?
Question here is whether the data, the IoT data captured from the network, so from the distribution and collection network, can be taken to the customer's own servers. So this solution is a cloud solution, but it is possible to also deploy the historian database incorporated with this on the utility's own infrastructure, so in their own data center. So from that perspective, assuming that's what the question that's being asked here, it is possible to have this data stored on your own infrastructure.
Yeah, that the historian and the server can be installed locally. Yep.
Is there a single login for Cityworks and Unity, or are they different logins for each?
Right now, it's a different login for each, but we're definitely working on a single identity and login.
Can the current Parsa Unity GIS assets be integrated into the Cityworks platform?
Yeah, I answered that question. The answer is yes, and there are options to be able to leverage the existing GIS data hosted in Unity with Cityworks.
Are the batteries on the RTUs replaceable? Do they support external power sources?
And the answer is yes, they are replaceable. Trimble Unity will show you a dashboard with the life of the battery, so you could start planning ahead of time before the units drain the battery. You can plan the replacements. And some of our units do support external power sources as well, whether it's using DC supplied power or through solar panels, for example.
Great, thank you. How am I notified of field alarm conditions?
So if a condition does occur and an alarm is detected, we have administration settings in Unity that allow our users to set up a group of users that will receive these alarms, either via text message on their phones or via email. And that's a mechanism to be able to communicate those alarms as they occur to those groups of users.
Does your hydrant pressure monitoring device require the hydrant to be pressure charged?
I'll cover that one, Lindsay. Yes, the answer to that is it does. It requires contact with the water system. So for a hydrant pressure monitoring application, you would need the hydrant to be charged. Some of our customers will use it as temporary deployments for modeling or for customer complaints or studies. But we equally have pressure monitoring devices that can be placed underground, and can be used year-round in, regions that have severe winter weather. So, those can be deployed at any underground chamber, be it, a PRV or other vaults or other underground fittings. Being pressure, it must have access to the water in the system in order to be able to measure the pressure.
Can system alarm, example, battery level, trigger a Cityworks work order?
At this point, no, it would have to be manually created. So if a user looks at the dashboard and it indicates there is a site or multiple sites that have low battery, you could select those sites and be able to manually create that battery replacement work order. That battery replacement work order workflow will have to be configured in Cityworks.
Can I use my existing flow meters with your solution?
Let me answer that. So we would pride ourselves that we work with both in terms of the drinking water and wastewater, that we work with all the major flow meter solutions that are out in the marketplace. So looking at water distribution initially, we've a variety of interfaces to existing flow meters supporting all the main protocols that those flow meters would capture the data or would provide as interfaces. So we can absolutely turn your flow meters that are out there into smart flow meters. And similarly on the wastewater side, again, we pride ourselves on working with all the major flow meters in the marketplace, and have been proven over many years with those meters. And again, standard interfaces into those flow meters to be able to capture both the velocity and the level as appropriate. So, the key thing is you can, with your existing flow meters, you can bring your existing flow meters to this solution and leverage the power of this solution to get much more value out of your investments in flow meters that you've already made.
How do you get the Trimble Unity data into ArcGIS Online to display in an operational dashboard?
Yeah, great question. So this would be using a product we created. It's called the Trimble Unity Remote Monitoring ArcGIS Connector. What it does, it creates a representation of a feature service that has the remote monitoring sites, the alarms and impulses that you could consume directly in a web map and be able to bring that into your dashboard. Or the alternative as well is to be able to store that data in the GIS, and you could just use native GIS maps to be able to bring that data into your dashboard.
Great. Okay. Thank you both Becky and Rami and Adrian. I hope everybody enjoyed today's webinar. If there were any questions that we didn't get to today, I will be sure to have someone reach out to you individually and get your question answered. Again, this was recorded and will be sent out tomorrow, and you can watch the playback. We thank you and have a great day, everybody.
Thank you.
Thanks, everyone.